Now, we come to the idea of unit cell. Lattice is finite or infinite? Infinite. I am only drawing finite portion of the lattice and leaving rest to your imagination, but you have to keep thinking that points are going in all directions at the same distance. Otherwise, that definition of periodicity is violated, the definition of equivalent surrounding is violated. If I say only this many points, then where is the neighbor to this point? There is no neighbor. So, we are assuming that that continues, this also has a neighbor and so on. So, it will go to infinity. So, it is an infinite structure. Infinite structure always difficult to handle. So, we seek for some finite representation of that infinity, and that is where the unit cell comes in. That if we select a finite region such that on translations by lattice translations, it fills the entire space, or in mathematical sense we call it tessellates the space. So, if we create a tessellation just tiling. So, unit cell is a tiling of the entire lattice or the crystal. So, the entire pattern can be considered as a tessellation, a set of tiles, and each unit tile is your unit cell. So, to define it, we will say unit cell is a region of a space, obviously a finite region of a space, let us put that. Fill the space. In what way? Fill the space without gaps or overlaps. So, filling the space without gaps or overlaps, for that a short word is that it tiles the space or tessellates the space. Because tiles, floor tile, you will not like one tile to overlap on the other tile, you will not like gaps between the tiles. So, the flooring is good only if tiling is satisfying this criterion, that there are no gaps and no overlaps. So, unit cell should satisfy the same criterion. So, unit cell is actually a tile of the whole space. One thing I am missing here, that if you want this has to be this repeating by lattice translation. This was required actually, is an important part of the definition which I was missing. Again, that a by 2 example. If I do not put this lattice translation, then a quarter of this tile also is a tile. Mathematically, it is a tile, it will fill the space by repetition, but then the repetition vector is a by 2. Repetition vector is a non lattice translation. So, that is why the green tile, although is a tile, but is not unit cell of my pattern. For unit cell, the repetition has to be by lattice translation. Now, an important question. Pattern and crystal I am interchanging. Pattern more general, it can be pattern of anything. Crystal is a pattern of atoms. So, is unit cell of a pattern unique? So, like I drew a square tile, a square lattice, and I drew a square unit cell. So, is there a one to one correspondence, one to one relation between unit cell and lattice? That is what I am asking. Yeah. Is it unique? Yes and no. You can choose a bigger one. A smaller also. Smaller. Okay. So, what we had selected is the smallest. So, the red unit cell was the smallest one. What you are saying that we can select a bigger one? How? What will be your choice of the bigger one? Can you guide me? How shall I go? 2 by 2. So, 2 by 2 of this. This was there in your mind? Sorry? Or you can change the orientation. Very good. So, let me change the color also to show the change in orientation. You meant something like this? Oh, so shape. So, you can change the shape also, it need not be perpendicular. Something like this. Are all these unit cell or will they qualify as unit cell? Which two? Square and rhombus. What is the problem with the blue?
Because all the points are not covered.
But did I say that all the points should be covered? Unit cell is a region of a space which by repeating by lattice translations fill the space. So, if I repeat the blue one, of course, I need to extend my lattice. Am I not able to fill the space? Is there any problem in filling the space? No. How much I translated from this center, from this lattice to this lattice. If you say center to center, that is a lattice translation. So, I am translating by lattice translations and I am filling the space. So, if we need to change the definition, then that is a different matter, but as given, the definition as given is accommodating this bigger blue unit cell also, no problem, because the shift is by lattice translation, and by shifting of all lattice translations, no, by shifting by these lattice translations. I just caught myself in saying by all lattice translation. If I shift this bigger unit cell by this, there is a smaller lattice translation also in that same direction. If I had shifted only by this, then obviously there will be overlap, then there will be an overlap. So, carefully again in my definition, or rather carelessly you can say, that I did not specify that repeating by lattice translation, repeating by all lattice do I mean all lattice translation, or a subset will do. So, a subset, let us accept that to accommodate, we want to be biased towards that bigger unit cell. So, by all, और उसको एडमिशन देने के लिए स्कूल में अपना कानून बदला, all or subset of lattice translations. Okay. So, blue one will qualify by a subset of translation. Non-primitive, very good. This is what we will call a non-primitive unit cell. So, the same word is coming and the two are connected: primitive basis, non-primitive basis, primitive unit cell, non-primitive unit cell. Non-primitive basis was giving you only a subset of lattice translations. So, whenever the repetition is by subset of translation, what is the characteristic of that unit cell in terms of lattice point, its relation to the lattice point. And whenever all lattice translations are being used, what is the relation of unit cell with respect to the lattice points?
There is no point in the inside.
No point
Inside the
inside. So, you see here there was a point in the bigger blue unit cell, there was a point inside. So, that point inside you cannot reach by tiling this pattern, yeah, without overlap. So, you have to overlap it. So, you have to ignore those translations. So, this is called, if you are repeat by a subset, then we call such unit cells primitive unit cell. Thank you for correcting. I was just checking whether you are awake or not. So, non-primitive unit cell, and all these kind primitive. Primitive. So, primitive is having lattice points only at the corners, you can see the way I have drawn, whereas non-primitive is always having some inside. This green one also is having one green lattice point inside. So, that gives us a classification of unit cell. And based on this, that whether you are using all or a subset, you are having two types of unit cell. Non-primitive, and you saw the example. And we had all this, and we had, you can see that we had two types of primitive itself. So, primitive also is not unique, the red is also primitive, this whatever color it is, orange. Okay. So, red and orange both are primitive, but they are different shapes, but they are still primitive. So, it is not that primitive is unique. Non-primitive also we are having two types, at least in this example. So, in fact, what to talk of non-uniqueness, the answer to this is no, of course. Not only it is not unique, there are infinite. It only depends upon your imagination. It all depends upon how crooked your imagination is. So, from a square you go to this orange one, or if I am more crooked, I can go this way. This is also my primitive unit cell. This also by repetition will fill the space. So, infinitely many you can see. This is a very, very important thing to keep in mind. And that will bring us to an important question, which we will deal with later, but it brings us to an important question. Then what unit cell to use to represent this lattice? And to begin with, I called it a square lattice, because points were on a square grid, and I selected this red square unit cell. So, all was happy and nice that I have a square lattice and I have a square unit cell. But now, if you say that I can represent it by such parallelogram unit cell also, so shall I call it a square lattice or a parallelogram lattice? That question we will look at in somewhat detail later.